We're going to do inverses today. So what we did yesterday with the composition of functions is one way that we can answer questions about inverse functions. There is a whole lot of writing here. What really you guys need to know is that the inverse of a function, f and g are two functions, and they are inverses of each other if you can take the composition of f and g and then g and f, and then you get x for both of them. So if you guys remember our last example yesterday, we were able to take the composition both ways, and then we got x as our answer. All right? So we can answer some questions, like, for instance, this one. So let's look at this particular example. We're going to show that these two functions are inverses of each other. If you get asked a question like that, you're looking for f of g of x, and you're looking for g of f of x. So you're looking in both directions, and you want them to equal x. So I'm going to say this equals x, and this equals x. And I'm going to put a little question mark, right? We don't know that it equals x right now, right? So could it equal x? We'll see. So let's start with f composed with g of x. So again, the definition of this is f of g of x. It looks something like that. What we're doing is we're taking this function g of x, and you're plugging it into the x that is in f of x. All right, so g of x is this entire function right here, the cube root of x plus 1 over 2. So this entire thing is going to go for this x right here that is in f of x. All right, so that is what we did yesterday. So let's try that here. So this is going to be the same as 2, let's see. Instead of x to the third, it's going to be g of x to the third minus 1. So this is the same g of x that is replacing the x. And what I'm going to do is I'm going to replace g of x with exactly the function that you see there, the cube root of x plus 1 over 2. So this is 2 times the cube root of x plus 1 over 2 to the power of 3 minus 1. So this right here is exactly what we substituted. And then from here, you can just simplify as much as you can, right? What happens to the cube root and the cube? Good, right? Cube root and cube always cancel. And then so this is going to get you 2 times x plus 1 divided by 2 minus 1. What happens to the 2's? They also cancel. So then you're left with x plus 1 minus 1. What happens there?
X.
Good, right? This is just going to get you x. So we showed one direction that we get an x. So for these to be inverses, both sides need to work. So we're going to show the other way now. All right, but first that we got x. Okay, good. We'll try the exact same thing with the next side, g of f of x. Right, so I'm going to put a little check right there. Right? We did show that it does equal x. So g of f of x now, again, this is you take the entire function f of x, and you plug it into the x that is in g of x. All right, so let me use a different color. This is our f of x now, this right here, and we're putting that into this x that is in g. All right, so this is our f of x right here. All right, so let's go ahead. This is going to be the cube root of f of x plus 1 over 2, right? I just replaced the x that is in g with f of x. And now let's actually replace it with the function that we see. All right, so this is going to be the cube root of 2x to the third minus 1 over 2. Oh, sorry, the plus 1 on top still. And then we simplify this as much as we can. So let's look inside of the radical. What's the first thing that cancels out? Good, right? The 1's cancel out. and then you're left with the cube root of 2x to the third over 2. What's the next thing that cancels out? The 2's, and then you have the cube root of x to the third. It's the last thing that cancels out. Good, right? The cube roots, and then this is just going to get you x. So we did show that these functions are inverses because when we took the composition of f and g of f, we did get that they both equal x. So then you can say that f and g are inverses. F and g are inverses. So let's do this one now, and then we're going to finish the rest tomorrow. So let's decide which of these functions are inverses of f of x. There's one way to actually find the inverse by hand, but for now, let's just test it. Let's just test which one works. So is g of x the inverse, or is h of x? Let's start by finding f of g of x. So again, when you're looking for inverses, you want this to equal what? You want it to equal x. So you're testing, does this equal x? So let's actually figure that out. So we're looking for f composed with g of x. You're taking all of g of x. So this is our g of x right here, x minus 2 over 5. And you're putting that into this x that is in f of x. So this is going to be 5 over g of x minus 2. And so let's replace that g of x with x minus 2 over 5. So this is going to be 5 over x minus 2 over 5 minus 2. All right, there's a couple things that we need to do before this simplifies fully. We have a complex fraction, so let's take care of the top and then take care of the bottom. The top is just 5. There's nothing really that we can do there. The bottom, we can try to get the same denominator. So I'm going to put this over 1, and then I'll do times 5 times 5. So then this is the same as 5 over x minus 2 minus 10 over 5. And then this is going to get us 5 over x minus 12 over 5. And then what do you get when you do a fraction over a fraction? How do you simplify that? You guys remember keep, change, flip? I'm going to keep the top, change division to multiplication, and then flip the last fraction. So this looks like a bit of a disaster, right? We are finished simplifying, and this gets us 25 over x minus 12. Does that get you x? No, so then this function is not an inverse. So you don't even need to check the other direction, because you know it's probably going to be equally a disaster. So let's try h of x. Of course, by process of elimination, you can figure out that h of x is the inverse, but let's verify that that is the case. So I'm going to plug in now h of x in for this x right here. All right, so when we do f of h of x, right, this is going to be 5 over, instead of x, it's going to be h of x minus 2. All right, and then when we plug this in, this is going to be 5 over what is it? 5 over x plus 2, and then minus 2. What's the first thing to cancel out? Good, right? The 2's cancel out, and then you end up with 5 over x. And then once again, you can keep, change, flip. This is going to get you 5 times x over 5, which does get you x. So it does work in that direction. And then if you did the other direction, you are also going to get that it works, right? So why don't we verify that? Let's try h of f of x. All All right, and then the x that is in h of x is the one that's underneath the 5. So this is going to be 5 over f of x is 5 over x minus 2. And then we have that plus 2. The first thing to simplify, again, you do your order of operations. There's some division happening there that we need to simplify first. So this is going to be 5. We can keep change flip again. This is going to be 5 times x minus 2 over 5 plus 2. The 5s are going to cancel out. And so this is going to be x minus 2 plus 2, which is indeed x. So we get that h and f are inverses. So I'm going to circle that one, right? H and f are inverses. Okay, so this page we can find the inverse of a function algebraically. So not like what we were doing yesterday where you're just verifying if two functions are inverses of each other, you're actually going to find the inverse by hand. The steps for that are pretty simple. I'm going to use number 1 as my example. So what you would do is first you would replace the f of x with a y. So y equals 5 minus 3x over 2. All right, you guys agree f of x is y? Good. Okay. And then what you can do to find the inverse, so from here onwards is going to be the inverse. All right, this is where you would swap x and y. So I'm going to put x in place of y and y in place of x. Right, so in blue is the original function, in red is my inverse function. And to get the actual inverse, you're going to solve for y. What can we do here to get the y by itself? What's the first thing we could do? Good, right? Times 2 on both sides. So then you get 2x equals 5 minus 3y. What's the next thing we can do? Good, right? Subtract the 5. So we get 2x minus 5 equals negative 3y. And what's the last thing we can do? Good, right? Divide by negative 3. And then you end up with something like this. Y equals 2x minus 5 over negative 3. Right? You wouldn't leave it like this just because this isn't the y that showed up in the original function. You actually have to change this back and say this is f inverse of x. And then you can write your answer. So that f with the little negative 1, that represents the inverse of f. You can't say that it's just y because it's not the same y that is in the original. Nope, okay. Good. All right, good with that one? Okay, so let's move on to this one. I think I had some marks there. Oops. Okay. So this one is another function. Again, the first thing that you would do is replace the f of x with a y. All right, and then once you do that, you would swap the x and the y. So this becomes x equals 3y plus 4 over 5. All right, how can we get that y by itself? Good, right? Times 5 on both sides, and then you get 5x equals 3y plus 4. What's the next thing we can do? Good, minus 4. We get 5x minus 4 equals 3y. And then we can lastly divide both sides by 3. And then you get y equals 5x minus 4 over 3. All right, you can't leave your answer like that. You need to replace that y with an f inverse of x. Again, that f with the negative 1, that is our notation that we use to denote an inverse function. So our f inverse is 5x minus 4 over 3. So we're just doing our reverse order of operations, trying to isolate the variable. All right, just have one more. Again, what's our first step that we do? Okay, good. So I'm going to replace this g of x with a y. All right, what do we do next? Good, right? I'm going to swap the x and the y, so this is going to be x equals the square root of 2y minus 3. And now we're going to try to get the y by itself. All right, what's the first thing that we would do here? Good, right? So I see a square root over this entire thing. The opposite of a square root is you square. All right, they're inverse operations. So those cancel out. You end up with x squared equals 2y minus 3. And then from here, pretty straightforward to get the y by itself. Let's add 3 on both sides. This is going to be x squared plus 3 equals 2y. And then lastly, divide both sides by 2. And then you end up with y equals x squared plus 3 over 2. And then y you can replace with f inverse of x. So we get f inverse of x is x squared plus 3 over 2.